In this set of notebooks, you will gain a comprehensive understanding of the workflow to generate delineated field boundaries using satellite imagery as input. The first notebook focuses on data preparation. This is one of the most important and often overlooked parts of geospatial deep learning. By the end of the first notebook, you will have a clean, organized, ArcGIS-ready training dataset that includes multi-bound satellite images, matching field boundary labels, and metadata files that ArcGIS needs to train a model correctly. In the second notebook, I'll walk you through adapting a pre-trained model for a new task and predicting accurate field boundary maps in Cambodia. In deep learning, most failures come from data problems and not model problems. If images don't align with labels, or the format doesn't match the framework required by the model, training will fail silently, or worse, produce misleading results. So before we train a model, we want to make sure our data is clean, consistent, and trusted. Let's start with the zeroth section. In this part, we install and import the libraries used throughout the notebook. Next, the notebook creates a very specific folder structure required by ArcGIS deep learning tools. Images in one location, labels in another, and metadata files at the root. This cell ensures images and labels are separated, naming is consistent, and nothing is ambiguous to ArcGIS model. This structure is what allows ArcGIS Pro to recognize your dataset appropriately. Now the exciting part, which is retrieving the dataset. In this section, the notebook connects to the Fields of the Board data store and specifically requires Cambodia. This dataset provides Sentinel-2 satellite images at 4 bands, pixel-accurate agricultural field boundaries, and it has coverage across many countries. The code implements 3 steps: reads the metadata, matches satellite images to label masks, and downloads only valid label image pairs. Section 3, Band Processing. This section often raises questions, so let's look at it carefully. The notebook converts 4-band Sentinel-2 images into a 12-band format. You may ask why. Because the ArcGIS pre-trained model for agriculture field delineation expects 12-band as input. This cell teaches an important lesson. Deep learning models care about the structure and not just the information. So the notebook shows how band order matters, how shape matters, and how model compatibility matters. This is a practical example of adapting your data to a model. Now we reach the label processing section. Raw labels from the dataset contain large non-sequential IDs and values unsuitable for training. So this cell converts them into clean sequential integers, 1 unique value per field, and setting background as 0. This is where we explicitly tell the model each of these areas or shapes is a separate agricultural field. Without this step, instance segmentation simply cannot work. Section 5, the main loop. This is the most important section of the notebook. For every image label pair, the notebook processes satellite image, processes the label mask, saves the pair with the standardized names, and records their relationship. When this loop ends, you have your training data. Section 6, Statistics Files. In most deep learning models, you need to have some statistics for your input data. This section then computes pixel statistics, band distributions, and dataset summaries and saves them explicitly. These files are what allow ArcGIS Pro to train your model correctly and reproducibly. Section 7, Final Verification. Before we close this pipeline, the notebook verifies everything. Counts to be matched, files exist, the structures are correct, and when you see all these checks, you know you're ready for the second notebook.